Okay, so we've discussed matter, the three states, properties, changes. Now we need to look at some components of matter. So what actually makes up the matter? So we really have two general categories. We have pure substances and then we have mixtures. So we will start with the pure substances first. As you can see on the screen, these are your elements and your compounds. The main idea about these pure substances is that they cannot be separated into smaller parts. All right, so let's start with the elements, okay? So elements are the fundamental substances that make up matter, okay? They cannot be broken down into anything else by chemical means. So the place to look for this is the periodic table. So each of those little boxes with their symbols like C or H or N, those are elements. And each element is made of one type of atom, and you cannot break that atom down into anything else. It is the smallest part that makes up that element. Now, the elements can combine with themselves, like there's H2 and O2 and N2. Those are called diatomics. You'll learn those later, but those are still considered pure, even though there's two of them. It's essentially just combining with itself. As of now, there are approximately 118 elements. 88 of those are natural, and the rest are synthetic or made in the lab. So when you're looking at the periodic table, a lot of the ones that are synthetic are kind of clear for their symbols, and usually they are named for some location or for a scientist, and they're relatively new. Now, many elements are found isolated on the Earth, but most of the time they are combined with other elements. And most substances have several elements combined together, and then you have to extract them. Compounds, on the other hand, are composed of a specific combination of elements that you can break down into those separate elements by chemical means. And these will always involve different elements, but usually in the same ratio. And a good way to understand this is the English language, or any language, right? So in the English language, you have 26 letters that make up the alphabet. Think of those as your elements. Now you put the letters together to make words, right? Think of those words as your compounds. There's only a set amount of letters, like a set amount of elements, but you can make an infinite number of words, just like you can make an infinite number of compounds. So compounds are unlimited, but elements are limited. Okay, and the main thing to remember for your compound, a lot of people get confused as to why the compound is pure. You have to remember that there are specific ratios for compounds. So take a look at this little diagram. If you see methane, that's CH4, water, H2O, carbon dioxide, CO2. Any scientist anywhere in the world that sees this formula will know what compound you are talking about. So these are ratios that cannot change. If you change the ratios, you have something else. For instance, carbon dioxide is CO2. If you take away an oxygen, you have carbon monoxide, which is a poisonous gas, compared to carbon dioxide, which is the gas that you breathe out. Okay, so both elements and compounds are pure. You cannot break them down into anything besides the elements that they came from. So elements themselves, you cannot break them down. Compounds, you can actually separate into those elements that made them up. But essentially, both of these are considered pure substances. Okay, mixtures, on the other hand, are variable in their composition. They can be taken apart into pure substances, physically, not just chemically. So you have things like soil, air, Lake Michigan. I have some pictures here of just the different types of mixtures, right? Some are liquid, some are gases. So you have chocolate milk, which is two liquids, right? It's the syrup and the milk, or it could be a powder, which is a solid and a liquid milk. You have your atmosphere, which is a combination of gases. You can see it's mainly nitrogen, a lot of oxygen, and then some other trace elements. And then you have the ocean water, which is salt and water. So all three of these are different types of mixtures. They have variable composition. Different parts make them up. As opposed to a pure substance that will always have the same composition. So what I showed you in these pictures here, the top is the element and the bottom is a compound with that element in there. So your top picture on the left is gold. At the bottom you have gold chloride. Both of these are considered pure because we know exactly what they are made of. In the right-hand picture, you have copper, and then you have copper chloride. So again, you have the element and then a compound that is made from that element. So again, these are pure substances. Now, mixtures can be classified into two different types. You have homogeneous and heterogeneous. So what is the difference? All right, homogeneous mixtures. These are the same throughout, like visually to your eye, it looks the same throughout. Another word for this is solution. So just take a look at my examples. The air that you're breathing right now, yes, it has nitrogen, oxygen, and other elements, but as you're breathing it in and being surrounded by this air, you cannot tell the different gases. When you drink chocolate milk, this is a mixture of liquids in general, it's the syrup and the milk. When you're drinking it, unless it's just made totally wrong, you cannot tell them apart. It just goes down as chocolate milk. Steel, that makes up buildings, right? These are two solids put together. Steel is not an element. It's actually iron with carbon built in to make it stronger. But when you see the steel, you don't see the two separate parts. These are homogeneous mixtures. So just some key points. They're generally homogeneous to your eye visually. They cannot scatter light. And what that means is if you flash light through one of these solutions, the particles are too small to be able to do anything to that light that is passing through. So generally the light just goes right through and it does not scatter that. That will come up in a different example in just a second. Another key fact is that homogeneous mixtures or solutions cannot be filtered. Usually the particles are the same size, and filtration usually separates mixtures by size. But if they are the same size, there's no point in filtering it. They'll both go right through. Okay? And for my pictures, just the left is steel, and on the right is the light scattering effect, which we'll talk about in a second. Okay, heterogeneous mixtures. These have regions with different properties. And another term for this is suspensions. Not the school punishment, but it's for the fact that the particles are suspended or they settle in layers. And if you take a look at these examples, it's pretty obvious that they have different properties. So you have oil and vinegar dressing. If you let it sit for 5 minutes or more, you can see it settles right into the two parts because oil and vinegar don't like each other. You have to shake them in order to put them on your salad as one continuous dressing. Chicken noodle soup, you can see the broth and the vegetables, the noodles, the chicken, lots of different parts. The human body itself, totally made of different parts, and you can totally see them at any given time. Not just outside, but inside as well. Salads, right? You see the lettuce, you see the fruit, you have croutons, dressing, lots of different parts that you can see. And then, of course, just wood. A lot of people think wood is homogeneous, but it's not. You can see these little eyes in the wood, the little striations, you can get the rings. And remember that wood is coming from a plant, which is a living organism, which would have a lot of different parts. Now, the mixtures that we have described can be separated physically, and we'll talk about these methods a little bit later because they will involve your own laboratory techniques that you will attempt. Okay, now here is where I said the scattering of light effect would come back. We have what's known as a colloid to talk about. And colloids are kind of in between solutions and suspensions. So the particles are larger than those in solutions, but they don't settle like suspensions. These are kind of hard to categorize, but one main idea is that they will scatter light. So if you shine light through a colloid, the light will become scattered. And a good example of this is fog. If you've ever driven in fog, then you can tell the headlights make like a scattering effect. It's not just a single beam, right? It kind of spreads out a little bit because those fog particles do that to the light. Some other examples are milk, and what you can see is for each colloid that I mentioned, I tried to show you the particles that would scatter the light. So in milk, you do have fat particles. Paint does have particles in there. If you've ever opened a can of paint, you know you have to mix it, right, because it tends to settle on the colors or the pigments from the liquid. Gel, you can see the gel in my little picture right here. It goes on smooth like in your hair, and then over time it kind of dries out, and yet it doesn't quite flow as a liquid, so kind of funky. Ice cream is like milk, right? It has the fat particles on the inside. And then toothpaste. Toothpaste is even funkier. We messed with ooblex in the classroom, right? The cornstarch and water. That's kind of what toothpaste is. So it's called a non-Newtonian fluid because it's kind of like a liquid, and then yet it stays on your toothbrush, and yet it's tough enough to get off the plaque from your teeth and so forth. It's just not a normal liquid. And you can see the particles right here. Okay, so what do you think? Homogeneous or heterogeneous? So again, you can stop this or you can just listen to my answers. Gasoline, I know you usually put just gasoline right into your tank. You don't really look at it, but, and I know like on the, where you get the gas that says like 10% ethanol on there, so like, well maybe that's some sort of mixture, maybe the ethanol looks different from the gasoline. It's actually homogeneous. You cannot tell the ethanol from the gasoline. So gasoline is a homogeneous mixture. A stream with gravel at the bottom. This is like a fish tank, sort of, right? So you have the water plus the gravel. That's heterogeneous. Air. We mentioned air already. You cannot tell the gases apart. This is actually homogeneous. Okay, now brass. Brass is actually not natural to the planet. Brass is actually copper and zinc combined. Now, it is a homogeneous mixture, but it actually has a more technical term. It's called an alloy because it's specifically a combination of metals, but brass definitely is a homogeneous mixture. Copper metal, I kind of messed with you here. Copper is pure. It's not a mixture. Just copper metal itself. I didn't say any compound, nothing like that. It is simply an element.